what other types of numbers might exist on the real number line that haven't been accounted for. Are there other gaps in the real number line? In order to find out, we use a systematic approach to represent every possible type of number that can be real. One way to do this is to define numbers as infinite decimal expansions. For example, we can take 1/4, which has the finite decimal expansion 0.25, but we can write it as 0.250000 and so on. Another example is 1/3, which is a rational number which already is characterized by an infinite expansion, 0.333 and so on. Then there are also numbers such as pi, which are irrational. This has an infinite expansion as well, but the sequence of digits is entirely unique. So pi equal to 3.1415926535 and so on. Rational numbers are distinct from irrational numbers since they will have a decimal expansion that eventually starts to repeat. This is not the case for irrational numbers. However, there's a very subtle issue that arises, not with irrational numbers, as unusual as they are, but with rational numbers. Remember, we said that we can write down an infinite decimal expansion for these numbers. But take, for example, the number 1. This has the decimal expansion of 1.000 and so on. But what if we tried to write the number down as 0.9999, etc.? Here, we can add arbitrarily more 9s, infinitely many, and the value approaches 1. It doesn't make any sense to talk about 0.999, etc. to infinity as a separate number. It's exactly equivalent to the number 1. But this situation isn't unique to the number 1. It happens for any number with a finite expansion. So for example, 0.15 can be written as 0.14999, etc. Strangely, the infinite decimal expansion of these numbers is not unique. They can be represented in both ways and represent the same number on the number line. We have two ways to write down the same number. It can be proven that this approach showing infinite decimal expansion does indeed show that the real number line is complete with no other gaps if we include both the rational and irrational numbers together.